Hi, hello, and welcome to my presentation, Cosplay Electronics for Beginners, H2.0, the sequel. This presentation will hopefully give you a slightly more advanced look into electronics and how to use them in your costumes and props than last time. So buckle up, strap in, get ready for something. So, who am I? Well, my name's Sam. Oh god, that's the wrong slide. That's the wrong slide. That's the right slide. Well, my name's Sam, or Sciencegey if you're one of the cool kids. I work in IT, so I'm horrendously unqualified for this presentation. I mainly work with servers, which may conjure images of, beautiful, clean data centers lined with millions of dollars worth of equipment, but really it's more kind of like the picture in the middle, if I'm completely honest with you. I do electronics stuff sometimes. I started out by getting an original Raspberry Pi as a teenager and progressively got more ambitious and crazy with my ideas. And in all of those cases, I've never really actually know what the hell I'm doing. So here's some things I made. So first off, Steve Protogen, an overly complicated and elaborate Protogen helmet made out of a 3D printed frame, laser cut visor, LED panels, the kind they use on those big video walls, and lots of very complicated electronics. And it's still not finished, and I don't think it ever will be. A cool keyboard, 3D printed, hand-wired, redocked split keyboard with a bonus custom number pad. That means something to probably two of you. If it doesn't mean anything to you, don't worry about it. A clock. But it's a clock. It tells the time. It was my first kind of proper project, and it uses a real-time clock module and an Arduino to tell the time. The things that clocks do, and a lot of other stuff. So, if you're one of the 5 people who turned up last time, you might be wondering, okay, so what are you going to do this time? And while I do ask myself that every single day, here's what I'm going to cover at this time. Microcontrollers, they're kind of like the backbone of any project that's a bit more complicated than just a few LEDs. And for them to work, we need programming. I know it's really scary to a lot of you, but I don't care. It's scary to me as well. And obviously, I'm going to be putting cool lights on things because apparently that's literally the only thing I do. And this presentation will also include the regulatory amount of fun. I just had to make that clear. So, first off, what is a microcontroller? Well, a microcontroller is basically a really small and simple computer on a chip. Hence the name, because it's a microcontroller. This means that they have a CPU, processor cores, RAM, memory, ROM, storage, and I/O, input/output, all in a handy little package ready for your consumption. Please don't actually eat them. Please don't eat them. That's bad idea. And to make things even easier, there's a million different types of microcontroller from a billion different companies. So let's have a closer look at them. So choosing which microcontroller platform to use in your project seems kind of scary at first, with all the words and stuff. But don't panic. Don't panic. In reality, there's only a few base platforms out there that everything is built upon. First, and possibly the one you might recognize, is the Arduino. It's been around basically forever, since 2005, and arguably kind of helped kick off the DIY electronics revolution. The chip that actually runs on Arduino is a Atmel AVR. This thing's literally been around since the 90s, and it's super simple and it's super cheap. And while it was really cool and great at the time, it's slowly been replaced by ARM Cortex-based chips. These things are based off the same chip design that's in your phone and is super fast and super cheap. The most common and probably most comparable to the AVR is the Cortex M0, however larger and more powerful and power-hungry variants are available for more complex tasks. And for something that needs a little bit more connectivity, you have things like the ESP family of chips. These things were specifically designed for use in Internet of Things. So they have loads of I/O, a built-in DAC, Hardware touch inputs. Some have even multiple cores. Loads of RAM, storage, Wi-Fi, Bluetooth, blah 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 blah, all that kind of stuff. Just to name a few features. And the new kid on the block, Raspberry Pi Pico. Do note that this is separate from the Raspberry Pi. The Raspberry Pi is a single board computer, and while you could use it in a project, it's probably a little bit over the top for the kinds of things that we'll be doing. The Pico is crazy fast, has loads of I/O that is configurable in like a really cool way, and is programmed with Python. And that's not even all of them, to be fair. Realistically, there's like loads out there to name, but those are generally the kind of ones you'll kind of run into in the wild if you look. So now that we've looked at all the different types of boards out there, we need to see what programming languages are out there so that we can program it to do stuff. Which programming language you use can vary based upon board. Traditionally, the most common language is some variation on C or C++. This is because they've been around like forever and are fairly low level, which means you can do a lot with very little resources. Problem is, they're also really complicated because they've been around since forever, and they can take quite a lot of learning to do. So, to this end, Arduino created a simplified version of C and C++ called Arduino. Creative name. It's quite a bit simpler than using pure C, but it can still be pretty complex. So because of this, CircuitPython is my personal recommendation. It's based on Python, so it's very beginner friendly. It's made by Adafruit and is open source, so it's got like a billion libraries out there, and it can run on quite a few boards. And the other really cool thing is you don't actually have to worry about flashing your programs because it's just drag and drop, which is like crazy. So now we've got all the boring stuff out of the way, let's go on to the fun bit, the project. So for this one, we'll be making something that might actually be useful to you, a set of cool LED goggles. Yeah. This project is fairly simple to both build and code, and is really customizable to basically whatever you want to make. And it has blinky lights, so yeah, you know, how predictable. So for this project, we will need some cool cosplay goggles. What one do you want to use? Up to you. Two 16-pixel NeoPixel rings, because they fit perfectly. Choice of microcontroller. We'll get to that later. Some way to power the goggles, either like USB or a battery, and the usual stuff that you need to do electronics projects, such as a 3-conductor cable, so that's 2 for the power, 1 for the data, solder, soldering iron, cutters, wire strippers, etc., etc. So, because this project is quite flexible in what you can like use it for, or even use it in, as long as it has a CircuitPython microcontroller and NeoPixels, you know, you can make it. So in this case, I've built 2 versions. One that's powered by a LiPo battery that uses the Trinket M0 as it has a built-in like battery management chip, and one that's powered by USB that uses the QT Pi RP2040, because apparently naming things is hard. So I'm going to demonstrate how to build the USB powered one because it's a lot simpler. And it's kind of a more universal design. However, I mean, you can basically use whatever you want and it should work. So to kick things off, we need to prepare the goggles for the electronics. So start by disassembling them. First, you unscrew the lenses and set them aside, and if they fly, please don't lose them. That would be awkward. So then what we need to do is we need to take the little bridge out that connects 2 halves together. It can vary, but usually you just kind of rotate it into like the slot and just kind of jam it. I don't really know how else to explain it other than just kind of do this, to be fair. Then we need to cut a little slot so that the electronics can go in from the front. And so use some little side cutters, snip, snip, snip the end of the little bridge slot thing off. And while we're here, we may as well just kind of file a little bit off of the red arrow indicated part, just to give a little bit more clearance for the wires. But if you don't want to, then you don't have to. It'll still work. It'll just be kind of more of a pain. So now the goggles are all sorted out for now. Let's start with the electronics. First, we need to grab our wire and kind of cut it to the correct length. It's better for it to be a bit too long than it needs to be, rather than like too short. As usual, you can always cut more off the end. You can't really glue it back on after the fact. Well, you can try, but it's not really going to work. So now you want to separate the three conductors at the end of each wire and kind of strip a little bit off. And personally, I'd recommend tinning the wires now. It will make our lives a lot easier in a minute. Believe me on that. So, this is the spooky part. It can be quite hard, a little bit tricky. If you just take your time, I'm sure you can do it. I did it, so I'm pretty sure you can. It's really important here to make sure you don't get your wires all mixed up. So as this ring is going to be at the front of the line, because it's where the microcontroller would attach, we need to put one of the wires in the data out pin, in my case the white one, and one in the power input, in my case the red one, and one on the ground, in my case the green one. What color you use doesn't actually really matter, as long as you use the same colors throughout the project. And while you can solder the wires in from the front or the back, I would personally recommend putting the wires to the front and soldering them to the back. While this isn't what I've done here, because I'm awkward, it just makes it a little bit kind of easier for the wire management in this case. When you're soldering from the front, you're really close to, as you can see, you're really close to like tiny LEDs, and you don't want to melt those. Not going to go well. So yeah, once you've done that, you just solder them to the pads. Simple as that. You don't go crazy. Don't like build a mountain. You just need like a little bit. It's just enough. So now that we've done one side, we just need to do that on the other side. So you'll need to work out how you want to route the wires. So if you want to see out of the goggles, then you'll need a little bit more careful to make sure the wires aren't like in front of the eyes. And when you wire it up, you need to make sure the data wire goes to the correct pin. So, as you can see from my very useful diagram, in this case, because we've wired the first one to the data out pin, we need to put the wire to the data in pin. If we don't do the wire out pin, you put the data in pin to the data out pin. It doesn't really matter as long as you don't wire them to the same pin, because then it's literally going to do nothing. It's not going to work. So now that the rings are wired up, we just need to attach the thing that makes it do the blinky blink. So to connect the rings to the microcontroller, we need to wire the power and ground pins on the first ring in the chain to the 3.3 volt and ground pins on the microcontroller. The data input pin on the ring needs to go to the data pin. In this case, I've chosen pin 3, the Mozzie pin, because it's right next to the other two. But what pin you actually use doesn't matter, as long as it can do output. And as long as you make sure it's the same as in the code, otherwise it's not going to work. Don't ask me how I know. Then we need to attach a power input to the whole thing. So again, because we're using a USB cable here, strip the ends off, and I found 5 volt and ground wires. Which ones those can be is basically just kind of guess, if I'm honest, because there's no standard. What you can really do is you can plug it into a USB port carefully. Don't short it out. That's not a good idea. Multimeter kind of just connect across the collection of wires and kind of see what gives you 5 volts. And also sometimes the 5-volt wires, so the power wires, are a lot thicker than the data wires. It's also a lot easier if you just get like a USB port, just a USB port and wire it, because then you know exactly what wires are going where. And to make sure all the wires don't get pulled off, I've committed the age-old sin of embedding the entire thing in a massive glob of hot snot. I do apologize to all the purists out there, but I don't care. So, don't worry, guys. I know most of you have probably fallen asleep by now, but we're almost there. We're almost there. So now that all the electronics are done, we just need to reassemble the whole thing, and it's going to look sick. And you're going to be like, whoa, I didn't even know you could do this with computers. Well, you can. So to get the kind of like nice glow, instead of just like multiple sharp points, I just grabbed some tracing paper and traced the outline of the lenses on it, cut it out and put it in between the neopixels and the lenses to act kind of like a diffuser. Then you slide the electronics in from the front using the slot we cut before. Remember that? It might be a bit of a squeeze, but put the bridge back in place the way you removed it. And now we can put the lenses back in place and screw them on. I find that using a little bit of blue tack or glue to kind of hold the neopixel rings against the lenses helps stop them kind of wobbling all over the place, and creating kind of weird, uneven lighting. But you might want that, if that's what you want to do. And then finally, we can just like glue the microcontroller in place, because we haven't used enough glue yet, I guess. And then, oh no, wait for it. Oh no, it's the programming. So, to be completely honest with you, I'm really not a very good programmer, which is ironic considering I'm the one with the programming in this presentation. But I know enough just to get by and to make some fancy blinking lights. So please don't complain when I do something wrong, because I already know. To make it much easier, we're going to use some of those pre-made libraries that I talked about before. And we're just going to kind of like glue them all together. But just because we're using someone else's hardware doesn't mean we don't have to do anything. First, we need to get like everything set up. So we import all the aforementioned libraries and create the variables we need. Top picture. And for those not in the know, anything that comes after those little hashtag things are comments. So the program will just ignore them. It's great because it lets you add little explanations for what your bits of code do. So please use them when you write your own programs. Please, I beg you. Then we have what's known as the loop, a part where your program basically just runs forever and ever, just like this presentation. Actually, it's pretty crazy coincidence. It's contained in a while true statement, which basically runs as long as true is true, which is forever. So that's pretty helpful. The first section basically creates the pattern by using setting each pixel to either black or a color, using some fancy maths that I don't entirely understand. The second section kind of writes the pattern to the pixels, because the pixels don't actually know what to do unless you tell them what to do, right? And then the final section controls what color the pattern should be. So in this case, it's using a color wheel function with a random number between 0 and 255, which will create a nice color that goes between 0 and 255. No, between red all the way through the spectrum back to red. And that is randomized. That color is changed at a random interval between every 1 to 8 seconds, which kind of looks cool, gives it a little bit of pizzazz, if you know what I mean. And now we've got the program. That was it. That was the entire program. It's really not that complicated. We need to put it onto the microcontroller, because otherwise it's not going to do anything. So fortunately, because we're using CircuitPython, it's amazing. It's super easy. Whoa, it's like the reason I picked it. If this was on Arduino, trust me, this slideshow would be about twice as long. So first, we plug in our microcontroller using the onboard USB port. Just make sure it's not already powered up. Otherwise, A, it's not going to work. B, you could potentially blow it up. And C, it's not going to reset, so it's not going to mount properly. It'll then mount just like any other USB drive as a drive labeled Circuit Pi, all caps. Now we just need to drag and drop the code.py and any libraries we need, which in this case is just the NeoPixel library, onto the drive, and that goes in, and the libraries go in the lib folder. And then the board will automatically reset whenever something new is dragged onto it. And assuming everything has been wired up correctly, which it isn't always a given, the NeoPixels should light up, and you should have a cool little spinny animation that looks sick, or something like that. And if they don't, then one, check everything's wired up correctly, and two, make sure you've got the correct pin set in the code, because again, don't ask me how I know that. And while it is possible to edit your code straight from the CircuitPy drive, I would actually recommend editing it on your PC and dragging and dropping it onto the drive. This basically means you don't lose your work accidentally if you just yank it out, because that would really suck, especially if it's like a really big program. You lose all that. It's just like, and then once you're done uploading it, just make sure to eject it before you unplug it, because again, it can get really sad if you just yank it out. Really sad, man. So sad. Yeah, so any of you that have fallen asleep, or if you have anyone who's next to you that's fallen asleep for the last 3 slides, do you mind just giving them a little nudge? Because it's over. This is it. It's done. That's how the sausage is made. See how simple it is? Easy. So assuming you somehow deciphered all these incredible instructions, you should have your own really cool goggles. And as a bonus gift, right, they might even work. And that's pretty crazy. I don't even believe it myself. Sunglasses emoji. And this is the actual end. The last one was a fake out. There's no more fake outs. So if you actually made it this far, then hi, thanks for watching. That's cool. I hope you had fun, and maybe you even possibly learned something, which would be pretty cool, actually. And you can find the files and more information on the project on my website, www.sciencegey.com. That's a lie. It's not there at the moment. It'll be there in tomorrow, probably. But you know, you can also find all the other stuff I've made if you want to, I don't know, laugh at it or whatever. Also, while there are loads of great source of information, learn.adafruit.com is pretty good, because Adafruit makes like 1 billion devices, so they make guides so you can buy those devices and make cool things with them. And this is where I stole the idea from. I'm just being honest. And circuitpython.org is where you can find more information about CircuitPython. It's pretty cool. And that's it. I'm done. So if you've got any questions, good questions, no bad questions, let's make that very clear, then hit me with the questions. Yeah. This question. Yeah. That's it. I'm done. So, you know. I agree with that turtle that's being washed in water. I don't understand, but, you know. Cool, I guess. Any questions in Twitch chat? Is anyone still awake? I see there's like, I don't know, like 6 people here. That's something. Hello. Yeah, woo! More than last time. Yeah, exactly. Got it right there. Twitch chats. Ooh, what is the most enjoyable project you have worked on for cosplay? That's actually a really good question. Because I can't answer it now. I'm going to be honest. The most enjoyable was the cool hat. It was cool. It looked cool. It was easy. I made loads of them. I made a lot of those hats. And it looks cool. And like you can do whatever you want. And whenever I'm wearing it, crazy. People are like, "Well, that hat's really cool." And I'm like, "No, it's not." And then it goes like, "Woo!" So yeah, but so what is the most difficult technical issue you ran into? Difficult technical issue I ran to. Well, the most difficult technical issue I ran to is when I literally exploded the microcontroller. That's a pretty bad on the kind of technical issue scale. So how did I troubleshoot it? Well, it didn't work anymore, unfortunately. So because it blew up, there was a hole in it. But I mean, you can get all kinds of crazy problems. I mean, if I'm honest, the best way to troubleshoot issues is to Google it and hope that either A, someone else has tried it, or B, some random Indian dude on YouTube has given you a, video on it. Hello, voice in my head. Yeah, you can if you want. That'd be cool. Yeah, okay. How much should one expect to spend on startup costs for things like tools, soldering iron, electronics, etc.? I kind of covered it in the last panel a little bit. Go watch it on YouTube if you haven't. Please don't actually watch it on YouTube if you haven't. But soldering iron, I mean, 50. I'd say that's always a really hard question to answer, but I would say to get kind of an electronics lab, I don't know, a few $100 at most, realistically. You can get loads of kits on Amazon and eBay and stuff that are like dirt cheap. And while they're not like super high accuracy components, they work, and that's what matters, really. And things like so like the QT Pi RP 2040 costs $9. Like, I mean, that's like crazy cheap for what it can do. So,
Okay. I have a question for you from the Discord, by the way. This is from Leonis Darkwatch. What was the most difficult technical issue you ran into, and how did you troubleshoot them?
Sorry, I already answered that one.
Oh, okay, you did. Okay, I thought you pulled it from. No, it's all good. This is from Duffwolf. How much should one expect to? Oh God, you're going in order. That's fine. That's great.
Far ahead.
Are there any tips you got from someone who's a complete noob at soldering? It looks very daunting, and I don't want to break anything on my first go.
Any tips? Well, if I'm honest, the best tip would be to break something on the first go. In the end, you learn by making mistakes, and if I'm honest, the easiest way is to make a mistake. Get like cheap kits and stuff, because then you don't have to worry about design and whatever, and just assemble them, because you're kind of figuring out as you go along. You'll be like, "Oh, this is an easy way to do it," or "Oh, this isn't a good way to do it." That's probably the best thing I could say, if I'm honest. I know it's a really non-answer, but I got no answers I'm going to give.
That's fine. This is from Tilla. I don't know if I pronounced that right. Having never soldered before, how do I get into that? Oh wait, no, this was that. This is pretty much the same question. I am
same thing basically. Yep.
Yeah, right. Okay, we'll go next down to Damien.
Cool.
Do you have the little robot from Bostic Dynamics, and what did you do with it?
Yes, I did. I 3D printed it. And I'm going to be honest with you, this is a really sad thing to say. I disassembled it because I needed the servos. The problem is making it was actually pretty simple. It was more the programming is like, we're talking like PhD level inverse kinematics and real time blah 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 whatever. It was a bit crazy. It's still on my shelf though. It still looks cool, but it doesn't actually do anything. So, but that's just a secret between you and me. Don't tell anyone else.
I have another question from Zuzu on the Discord. Do you show any cosplay projects, and where can I find your cosplays?
No, and you can't because I don't really post stuff on the internet. I know it's crazy, but yeah, I just don't. I kind of make whenever I make stuff, I'm just like, oh, that'd be a really good idea. I kind of make it, and then it just goes on a shelf. It doesn't really get like, so yeah, I'm just kind of one of those weird people who makes loads of random stuff and then just doesn't put it on the internet. But again, you can look on my website. I've got some stuff there that I've documented, but the problem is a lot of the stuff I've made, I didn't even take pictures of them because I made them for like a purpose, and then I destroyed it when I needed the parts because I'm really cheap like that.
Yeah. Here's a question from Program Mousefall. They ask, did you work with ATTINYs at Tinnies? I have a small IT Tinies, sorry. I have a small project and managed to fry one. The temperature sensor that activates a fan at a temperature.
Oops. Okay, yeah. AT Tinies are pretty cool. Again, they're basically like really tiny AVRs. There's some of them are actually like really cool. They got loads of cool little kind of bits in them. But so if you're trying to activate a fan, it might have been that you tried to plug the fan straight into the AT Tiny. Problem is it can't deal with one, the voltage, and two, the current, so it'll just explode. So you have to use either a relay or a transistor or a MOSFET or something like that, and attach that to one of the pins, and then that will then activate the fan. Also, if the temperature sensor was 5 volts, I think. I don't think the AT Tiny can do 5 volts, or it's either 5 volts, 3.3 volts. But if you have a voltage mismatch, then you can also fry it that way as well. And when you're working with like a bare chip, there's no protection circuitry. There's no hand holding. If you do something wrong, it's just going to kind of blow up. But so you just got to kind of try it.
Yeah. Quick question from Sapphire. What is the most fun project you've built?
Most fun project I've built? Most fun project I've built. If I'm honest, that's actually probably the keyboard. Even though it's not really kind of an electronics project per se, because it's basically just someone's done the code already, someone's done the design already. You just solder wires across the rows. It worked. Step one, it actually worked, which was pretty cool. And step two, it was really easy, really quick, really simple, and I use it every day. So but yeah, because I finished it. I mean, in the end, that's kind of the fun thing about project. Obviously, making it's fun, but also finishing it is really cool when you can look at it and go, "Wow, I made this," instead of being looking at your shelf and going, "Wow, there's 60 things on it, and I haven't finished any of them." And it's all just kind of sad, but
Mm-hmm. Okay. Next up, let's see. We have fun project, craziest project. What is from Dio Broxis? What is your preferred location to compile your libraries from?
Compile my libraries from? Oh man, that's a great question. Compile my libraries from? I'm not. If I'm honest, I'm not entirely sure what you mean by that question, but I'm just gonna take a wild guess. So, CircuitPython libraries, you can download them. Adafruit have a big GitHub repository which is just full of all the libraries they've made, and you can download them and just chuck them on there, and they work. They kind of test them and stuff like that, and that's really cool. But also there's kind of a lot of, sometimes you just trying to do one really specific thing, and then you just find some random dude that's like, oh, I was trying to do that specific thing as well, and I made it, and I made it open source, so now you can just download it, and it's like, wow, that's pretty crazy. It's pretty cool. Yeah, so that's kind of, I'm guessing that's what you meant.
Yeah, it's awesome that you make it open source too.
Yeah, exactly. If you're making something, make it open source.
Bless. All right. This one's from Jet the Husky. Do you have any tips or guides for getting some OSC working? I have some ESP boards, but don't really know where to go from there. Wireless control.
I see. So, wireless control. Okay, that's cool. Funnily enough, I haven't actually ever done OSC with ESPs before. I have done OSC before. I did it with, again, CircuitPython. So man, that's really hard. I mean, if I'm honest, the best thing is to Google it. But OSC kind of, a lot of libraries are pretty much the same kind of thing, even though they're all, because in the end they have to do a specific function. That's their job, is to do a thing. And there's only kind of so many ways you can do that thing. Yeah, that was a terrible answer to actually a really good question. Google it, lol. But yeah, I unfortunately haven't worked with it before, so I can't really give a professional opinion or whatever.
Okay, next up is from Claire John. What website or websites or brick and mortar storefronts do you like using for getting your parts from?
That's a great question. Parts. So it depends. Personally, I'm in the UK, so obviously, if you're in the US, your choices are completely different. If you want really, really, really cheap stuff of questionable quality, eBay or AliExpress, you can find like everything for really cheap. Possible it's a knockoff, but in the end, if it works, it works. For stuff that you want that's kind of like more of a critical thing, or if you're going to make loads, if you're going to, kind of mass produce, I don't mean that mass produce in millions, but like make a few and possibly 50 of the same thing, then I usually go to Mauser, because I just do. Obviously, their stuff costs a lot more because it's genuine. It comes from the manufacturers. They're a distributor, but you can get them in bulk. You can get pretty good bulk, like discounts if you're buying more than like 10 or 50 or whatever. You can get them in reels if you're talking about like surface mount components. I mean, there's also Element 14 or Farnell if you're in the UK, and there's another one. My brain has just also, if you're in the US, you can get stuff directly from Adafruit or SparkFun, which is pretty cool. They're generally kind of the cheapest place you can get it from. In the UK, there's Pi Moroni. They do more than just Raspberry Pi stuff. And also, this is a weird flex, but I live in Cambridge and there's a Raspberry Pi store. So I've been there a few times. So, but it's kind of, just kind of look around and see, because some sites will have like the thing you want, and other sites just won't if you're looking for a very specific thing. And searching's a lot easier on like big sites because they've got like parametric filters and stuff. So if you're like, I want a voltage regulator that's low dropout and is 5 volts and blah 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 whatever, then you can find what you want. But yeah, kind of just look around really.
Yeah, it's cool. I did not know there's like a place in the UK that just sells Pi's. Also in the chat, someone mentioned Micro Center in the US for. Oh yes, Micro Center. That's another good one if you're in the US. Yep. Mm-hmm. And that stuff's pretty good value as well. Yeah. So next up, we got the Gal Deathpaw. They ask, what tips would you give for someone starting out in cosplay electronics?
What tips? One, have cool ideas. That generally helps, just kind of in general. But so if you already make like cosplay stuff, then as I said in my last presentation, I keep referencing it. Sewing and soldering is actually pretty similar, believe it or not. You need a lot of kind of fine motor skill, and you need to kind of be aware of the dangers of the tool you're working with, because a sewing machine will, jam a needle through your hand without caring, and a soldering iron will burn your face off. So slight over exaggeration, won't actually burn you. Wouldn't set you on fire, that is, it'll burn you if you touch it on you, so don't do that. But yeah, have cool ideas. There's lots of cool there's some cool YouTube channels that and websites and stuff that have, like, they've made lots of props and stuff Prop Academy, I think. Oh my god, I can't remember the name. They're really good. Adam Savage, he's got a channel tested. That's actually pretty cool. And I'm not going to name all of them because there's loads, and also I don't want to embarrass myself. But yeah, so and start off with something simple. So something like if you want to do like a cool sci-fi blaster, right? Just get a toy gun, like a Nerf gun, and you can paint it. You can glue bits on, whatever, and just put a few LEDs in it, and that's it. It's that simple, but it looks really cool. So yeah, you just kind of you know, just kind of come up with a good idea, but also something that's not like crazy complicated.
Okay. This is from I don't know if this is a name, but this is from question asker Morbius Enjoyer. How do you learn the programming for?
Sorry. What?
How do you learn? No, you're good. How do you learn the programming for devices you don't already know? Is it hard to find the right libraries for everything?
I usually Google it, and then I kind of bash my head on my cool keyboard a lot until either A, I get a horrible migraine, or B, I figure it out. I'm really bad at learning to do stuff. Because I'm not a programmer, I look at all these programming things, it's like my brain just turns off. So I generally what I'll do is I'll search for the thing I'm trying to do, and then add whatever platform I'm trying to use. So if I'm trying to make a smart temperature sensor, I'll be like, temperature sensor ESP 8266 code or diagram or walkthrough or whatever, and you'll probably find something. And then you can kind of work from there, especially if you're kind of start with simple stuff, because if you go in right at the top trying to do really complicated things, unfortunately you're not going to get anywhere unless you're that that kind of person.
Mm-hmm. Here's a question by Toolbox. Have you ever tried to design a controller board from scratch? If not, would you be interested to?
Controller board? As in like a microcontroller board? No, I'm not that cool. I've made circuit boards before. I've made PCBs for much larger things. But yeah, I've never done a microcontroller before. That's kind of a bit above my pay grade, unfortunately. But well, probably fortunately, to be fair. But yeah, so it'd be cool, I guess. But I'm not really smart enough to do that. There's lots of weird stuff when you get to those kind of really tiny, high performance stuff. You just got to like.
Okay. Here's a question by Ecal. What are the main components that are needed to make the circuitry for a protogen head? Also, where would it be best to buy them?
Okay, that is a really hard question to answer. I don't have forever. But the basic thing is, so you need screens. You can find them basically anywhere. I went for 64 by 32 panels, but there's a lot of different sizes. You'll need a controller board. So I went for an ESP32 because it's got EMA and it's also got loads of pins, which is cool, and it's got wireless, blah blah blah, whatever. I also you also need that's kind of it really. You'll need like a multiplexer, that kind of stuff. Where can you buy it? AliExpress, if I'm honest. You can find lots of cheap stuff. Those panels, you can't really buy them kind of like as a product from like Mauser or whatever, because they're used in enormous panels. So the companies buy them straight from the manufacturers, but some ways to slip under and get onto the market that way.
Mm-hmm. A question from Knox. If you happen to know, is there a guide to Circuit Python on what certain code means, or a website going into detail on Circuit Python to understand coding more? Besides YouTube, that is.
Okay. I mean, that sounds like you're looking at it and you're like, I don't really understand what this code stuff means. Start off by looking at just normal Python stuff, because even though they're technically different languages, like they're very similar. If you can do something in Python, you can probably do it in Circuit Python. So try looking for Python, just general Python, like beginner videos, obviously, or websites or whatever. Don't really know any off the top of my head. Sorry. But yeah, just kind of, and then you can be like, oh, okay, now I want know how to do this, or now how to do this, or whatever. I just kind of learned by bashing my head on my fancy keyboard a lot. So
okay.
yeah.
Here's a question by Kahek. Where do I tuck the circuit board on my body to keep it safe?
Keep it safe. That is a great question. I would suggest not putting it in any internal orifices. Personally, that's a bad idea. Again, it depends what you're doing. If you're doing a like a cool shirt with pixels on it, then somewhere. If I'm honest, it entirely depends on what you're trying to do, how big a circuit board is, what type of circuit board is, how, you know, all that kind of stuff. Just don't put it inside your body, please. Please, for the love of God, don't do that. That's a really bad idea.
The Gal Death Paul asks again, what cosplays are the best to use electronics in, or types of cosplay?
Okay. Yeah. Basically anything. Obviously, this is what I'm going to say. But anything that uses lights or sound, is pretty good because again, you can do like sound stuff, as well. So you can have, you know, if you touch in a certain place, then it makes a sound or whatever. I mean, you can do obviously more like kind of animatronic stuff, but that gets quite complicated. If you can think of it, and you're a mechanical engineer, then great, go for it. But I couldn't. But yeah, stuff that's got lights, that's really cool. Again, one I saw that was really cool was like a t-shirt that had like a NeoPixel grid on it, and like they could like put messages and stuff. I'm like, wow, that's really cool. Don't want to think about washing it. God, that would be awful. But cool goggles, guns, like sci-fi guns and stuff. They can look really cool if you put lights, and if you use something like NeoPixels, you can do like animations and stuff. So yeah, it's kind of, you know.
For sure. Let me grab. Okay, here's a quick question from CM John.
Cool.
Do you use CAD software when making your projects?
Yes, I do. I use Fusion 360 because that's what I use. If you want to use Google SketchUp, go for it. But yeah, for more complicated stuff, I certainly use CAD. But simple stuff, you can just, like the goggles, for example, I just kind of YOLO'd it because you don't need a model to be. I didn't need to 3D print anything. I didn't need to laser cut something. I just kind of snipped it with a pair of scissors. So yeah.
Okay, I think we can do 2 more questions here. So,
okay.
So this is from Claire John 1. They ask, you've said that what your favorite project to work on was. What has been your least favorite project to build?
Oh man. Okay, that's a really good question. Least favorite, the ones that didn't work, the ones that were really awkward and were just like a massive pain, and they really sucked, and I never finished them. There was one I did. Oh God, what was it? If I'm honest, I'm gonna say the little spot. The little Boston Dynamics log thing, that was kind of the worst one because I built it all and I'm like, I don't know how to use this. And I was just like really just like,
oh.
So yeah.
Yep. And then for our last question for this event, yep. This is from Talchanka. Do you believe in modularity for replacing damaged or obsolete components in cosplay electronics? In parentheses, this means connectors over directly soldered wires, custom 3D enclosures for a certain part that can fit in a certain spot.
Yes, that is a great idea. Serviceability is really important. If ever you've done, not that I have, but if ever you've worked in an engineering field, you know how useful serviceability is. If you ever try to fix like a consumer electronic device, you will know how amazing serviceability is. Connectors, yes. Enclosures, yes. But there's also kind of a practical limit to how crazy you can go with all your crazy bits. But yeah, so yes, that is a good idea. Please do that. So yeah, we've got 10 seconds to go. We kind of stand here. Cool.